Hello and welcome to our video about the mysteries of the universe. In this video, we'll dive deep into everything you need to know about our cosmos. Let's start at the beginning. The term universe is derived from the Old French univers, which originated from the Latin universum. A term for universe among the ancient Greeks was tau painu, the all, defined as all matter and all space. So, what is the universe? The universe, in the broadest sense, is everything that exists physically, including all of space and time, all forms of matter and energy, and all the physical laws and constants that govern them. It encompasses all of space, all the galaxies, all the stars within those galaxies, and all the particles that make up those stars, galaxies, and intergalactic spaces. The universe includes the tiny subatomic particles we cannot see, like quarks and neutrinos, as well as vast cosmic structures such as galaxy clusters, and everything in between. Even empty space is part of the universe, as it can have properties such as a temperature and it can carry energy in the form of quantum fluctuations or gravitational waves. The size of the universe is mind-boggling. Scientists estimate that the observable universe, the part we can potentially observe from Earth, is about 93 billion light-years in diameter. However, the entirety of the universe could be infinitely large and could even contain an infinite amount of matter, but the truth is we don't know for certain. It's also thought that our universe might be just one of many in a multiverse, but this concept remains speculative and not currently supported by direct evidence. The Big Bang Theory is the prevailing cosmological model for the observable universe from the earliest known periods through its subsequent large-scale evolution. It describes the development of the universe from a very high-density, high-temperature state and offers a comprehensive explanation for a broad range of observed phenomena. The Big Bang Theory emerged in the 20th century, built upon observational evidence such as the redshift of distant galaxies, indicating the universe is expanding, the abundance of light elements like hydrogen and helium, and the discovery of the cosmic microwave background radiation. Here is a simplified version of what the Big Bang Theory proposes. The universe began around 13.8 billion years ago as a hot, dense point nearly infinitely small. There was a violent expansion, the Big Bang itself, and the universe started to cool and expand, eventually becoming larger and cooler. As it expanded and cooled, matter began to form, and eventually, atoms of hydrogen and helium were created. Over vast stretches of time, these atoms gathered into clouds and eventually formed stars and galaxies. The universe continues to expand and cool to this day. The Big Bang is not a description of the creation of the universe, but rather a description of the evolution of the universe over time. It's also worth noting that the Big Bang Theory doesn't suggest that the universe exploded from a point in space, but rather that every point in the universe was once very close together, and space itself has been expanding ever since, carrying galaxies with it. The bounce theory, also known as the Big Bounce theory, is a hypothetical cosmological model for the origin of the known universe. It was originally suggested as a phase of the cyclic model or oscillatory universe interpretation of the Big Bang, where the first cosmological event was the result of the collapse of a previous universe. In simple terms, the Big Bounce theory suggests that our universe didn't originate from a singular Big Bang. Instead, it theorizes that the universe cyclically expands and contracts. This suggests that the current expansion of the universe will eventually halt, reverse into a contraction, a big crunch, and result in a new Big Bang, or Big Bounce, starting a new cycle of universal evolution. The specifics of the Big Bounce theory vary from interpretation to interpretation. Some versions of the theory suggest that the universe's cycles of expansion and contraction occur indefinitely, while others propose that the cycles have a beginning and an end. It is important to note that the Big Bounce theory, while interesting, is speculative and isn't as widely accepted as the Big Bang theory. Many aspects of the theory are currently beyond our ability to test scientifically, and it's still being studied and debated within the scientific community. Spacetime is a concept in physics where three dimensions of space, length, width, and height, are combined with the dimension of time into a four-dimensional continuum. This idea was first proposed by the physicist Hermann Minkowski in the early 20th century, and it was later integrated into Albert Einstein's theory of relativity. In the theory of relativity, spacetime replaces the traditional idea of separate, absolute space and time. Instead, space and time are interwoven and can't be separated from each other. Objects in the universe, including light, move along paths through this four-dimensional spacetime. An important feature of spacetime in the theory of relativity is that it is affected by mass and energy. A large mass or energy density can curve or warp the spacetime around it. This curvature is perceived as gravity. So, in this view, the Earth orbits the Sun not because it is pulled to it by a force called gravity, but because it is moving along a curved path in the spacetime that is warped by the Sun's mass. The shape of the universe is a subject of debate among cosmologists. There are three possible options for the shape of the universe. It could be flat, like a sheet of paper; it could have a positive curvature, like the surface of a sphere; or it could have a negative curvature, like the surface of a saddle. As per the theory of general relativity, the shape of the universe is determined by its density. If the density is above a critical value, the universe will be closed and positively curved, similar to a spherical shape. If the density is below the critical value, the universe will be open and negatively curved, like a saddle. If the density is exactly at the critical value, the universe will be flat. Observations of the cosmic microwave background from the Planck spacecraft suggest that the universe is flat with only a 0.4% margin of error. This doesn't definitively rule out a curved universe, but it strongly suggests that if the universe is curved, the curvature is so slight that it's undetectable with current technology. However, it's worth noting that when we talk about the shape of the universe, we're really talking about its observable part. The entirety of the universe beyond what we can observe could be vastly different and infinitely large. But with the information we have now, we can only hypothesize about the true shape and extent of the whole universe. The composition of the universe is a topic that has been studied by scientists for centuries. The current best understanding is that the universe is composed of three main components. Dark energy makes up about 70% of the universe. It is a mysterious substance that is causing the expansion of the universe to accelerate. Dark matter makes up about 25% of the universe. It is a mysterious substance that cannot be seen directly, but its presence is inferred from its gravitational effects on visible matter. Ordinary matter makes up about 5% of the universe. This is the matter that we can see and interact with, such as stars, planets, and galaxies. In addition to these three main components, the universe also contains a small amount of electromagnetic radiation, such as light and radio waves. This radiation makes up about 0.01% of the universe. Lastly, let's discuss the fate of the universe. Will it continue to expand indefinitely? Or will it eventually collapse in on itself? The truth is, we don't know for certain. There are three main theories about the fate of the universe. The Big Crunch. In this scenario, the expansion of the universe will eventually slow down and reverse, causing the universe to collapse in on itself. This would eventually lead to a massive singularity, similar to the Big Bang. The Big Freeze. In this scenario, the expansion of the universe will continue forever, but at an ever-slowing rate. Eventually, all of the stars will burn out and the universe will become a cold, dark place. The Big Rip. This is a more recent theory that suggests that the expansion of the universe is accelerating due to dark energy. If this is the case, the expansion will eventually become so rapid that it will tear apart galaxies, stars, atoms, and even subatomic particles. And that's it for today. I hope you found this journey through the universe as fascinating as I do. Thank you for watching. Please remember to give this video a thumbs up, subscribe to the channel, and leave a comment with your thoughts or any questions you might have. Until next time, this is YT Science Addict, signing off.